Okay, let's look at the practice exam 2, problem number 2. All right, so we have this rational function, and we want to take a bunch of limits and find the horizontal and the vertical asymptotes. All right, so let's do that. All right, so we want to take the limit as x approaches infinity. All right, so when you take the limit at infinity, all you really have to look at is the leading terms. So leading term on top and leading term on the bottom, because those two guys will dominate the behavior of the whole function. All right. So you have limit as x approaches infinity. Right? So leading coefficient on top is 2x squared over leading coefficient on the bottom is x squared. Right? Then you can cancel x squared on top and x squared on the bottom. So this will give you, right, just the limit of a constant 2 is the same constant, so it's 2. Right? Next, limit of the same function as x approaches -1 from the right hand side. Right, so let's look at that. Right, first I'm gonna factor out the numerator and the denominator, see what we get. All right, so if you look at the denominator, it's going to be, let's see, quantity x here, and the x should be here. So we have to, it's 2, so it's going to be probably 1 and 2. So put 1 here and 2 here, right? So we have to get a negative sign, which means that the 2 will have a negative sign, 1 would have a positive sign, right? So this should work out. And the top numerator can be factored out as, right? So you have a 2x here, and you have x here, right? Then we have to have 1 and 2, so seems like, let's see, it's going to be -1 here, and a positive 2. Would that work? Right, -1 times -2 is -2, and let's see, 2 times 2 is 4, and plus -1 is positive 3. So that's that. All right, then take the limit. All right, so just kind of plug it in. So this is going to be equal to limit as x approaches -1 from the right, right? Then here's the function, right? So you have 2x minus 1 and x plus 2. Unfortunately, we cannot cancel any of the factors, but if you have common factors, you can go ahead and cancel them. All right, but in this case, that's not the case. All right, so first thing you do is just to plug it in and see what happens. Plug in -1 here. So 2 times -1, so that will be -2, minus 1, so it's -3 here. Right, times, right, plug in -1 plus 2, so you have 1, all over -1, so it's going to be actually 0 here, right? But we have to be careful since x is approaching -1 from the positive side, so you're adding 1, so it's going to be approaching 0 from the positive side, times, right, put -1 here, -1 minus 2 is -3. Right, so -3, and there's -3 on the bottom, you can cancel those. All right, then you have 1 on top, then you have a 0 on the bottom, so this is going to be infinity. Whenever you have non-zero on top and 0 on the bottom, it's infinity. Then you have positive because it's 1 here, it's also positive, so it's going to be positive infinity. All right, so limit goes to positive infinity on that one. All right, how about x approaches 2 from the negative side? So let's do that. It's the same deal. So we take the limit as x approaches 2 from the left, right? Then you have quantity 2x minus 1 times x plus 2 over quantity x plus 1 times quantity x minus 2, right? So this is equal to, right? So you have 2 times 2 is 4 minus 1, so it's a 3. Multiplied by 2 plus 2 is 4. And 2 plus 1 is 3. And you have 2 minus 2. So now that's 0, right? But since x is approaching 2 from the negative side, minus 2 is still going to be approach 0 from the negative side, right? So cancel 3's and 3's, right? Right, so non-zero divided by 0 is going to become huge, right? Positive number divided by negative number is negative, so it's negative infinity. All right, so using A through C, we can find the horizontal asymptotes and the vertical asymptotes. Right, part A indicates that the limit at infinity is 2, which means that the horizontal asymptote is y equals 2. So we have a horizontal asymptote is y equals 2. All right. And B and C indicates that since as x approaches -1, it blows up from the positive side. So you have a positive infinity there. Same thing happens when x equals 2. So B and C together, right, tells you that the vertical asymptotes are, right, one of them is x equals, right, you look at this number, right, -1, and also x equals positive 2, right? Just to comment that if these two limits, let's say one of them doesn't go to infinity, or negative infinity or positive infinity, there is no vertical asymptote there, right? So it has to go to either positive infinity or negative infinity in order to have a vertical asymptote there, right? But anyway, so this was practice exam problem number 2, right? I hope that this was clear.